Okay, hi everybody. It's time for us to get crack-a-lackin' and take some notes. Remember the video you watched yesterday about note-taking? And if you don't have a notebook yet, you can just take notes on a sheet of paper, and then once you have your notebook, you can put those notes in there. So today we're starting with notes number 1. And our title is Set Notation and Number Sets. And we talked about this a little bit while we were meeting together in our Zoom meeting. So we're going to go ahead and jot down the important symbols, what they're called, and an example of each. So the first thing you want to do is go ahead and write down set A, which has elements 1, 2, and 3, set B, which has elements 2, 3, 4, and 5, and set C, which has elements -2, -1, 0, and 1. So sets are typically named with capital letters. And remember that you can always pause at any time. If I'm going too fast or you need to just take some time to think or to write something down. Okay, so one of the symbols that we want to use is the set braces symbol. So we have these curly braces. They're called set braces. And an example would just be to say that the set with elements 1, 2 is the set with elements 1 and 2. I'm just putting into words what the symbols mean. Okay, here's the next symbol. It kind of looks like the letter E or like a C with an extra line. And that symbol means is an element of. So we could say, for an example, that 2 is an element of set A. If you look up to set A, you'll see that 2 is an element of that set. Okay. The next symbol is the union symbol. It looks like a capital U or a horseshoe. And in math, it means or. And in math, or means one or the other or both. So for an example, if we have A union B, we take the elements that are in set A or in set B or in both sets, and we get the set with elements 1, 2, 3, 4, and 5. So we had 1 in set A, we had 2 and 3 in sets A and B, and we had 4 and 5 in set B. So that covers everything from A and everything from B. Okay, now we have the intersection symbol, which looks like an upside down U. Maybe this one is the horseshoe. And so this means intersection. And for that in math we say and. So the intersection is the overlap. It's what they have in common. So A intersect B would be the set with elements 2 and 3 because those are the only elements they have in common. And then we have the empty set symbol. Sometimes it's referred to as the null set, so empty or null set. And technically, you're not supposed to put set braces around it. You're not supposed to write it like that. You can just write it without set braces. But another way to express the null set or the empty set is to have set braces with nothing inside. It means the same thing. Okay, so for an example, we could say that if we have set B intersect set C, so we're looking for the points or the numbers they have in common, the elements they have in common. We look at set B, we look at set C, we don't see anything in common, so since there's nothing in common, we have an empty set. Okay, I just realized that what I was writing at the bottom might have been outside the window, So there you go. Hopefully you can see it all now. Okay, let's move on. All right, the second thing we're going to talk about today are the number sets. So this is a very vocabulary intense lesson today. We really need to understand when we use these words what they mean so we can understand one another. So let's review what each of these number sets means. Let's start with the natural numbers, and those are also known as the counting numbers. So when you learned to count when you were little, you probably learned 1, 2, 3, etc. So the natural numbers start with 1. So I'm going to use set braces, 1, 2, 3, etc., following that pattern. Now the whole numbers also include 0. So the set of whole numbers would have 0 and then 1, 2, 3, etc. The integers are the whole numbers and their opposites. So here's where we introduce some negatives. So the set of integers, ... -3, -2, -1, 0, 1, 2, etc. Okay, now remember that rational numbers are numbers that can be written as a fraction. That's one way to think of it. When I see the word rational, I see the root is ratio, and I think of ratio as meaning fraction. Now, it is a little bit more specific than this. Numbers that can be written as a ratio of A over B, where A and B are integers. So A over B, such that A and B are integers. And we know we can't divide by 0, so we say, and B is not equal to 0. So, for example, if you had 7/3, you have an integer over an integer. That is a rational number. If you have 7, you can write it as 7 over 1, 70 over 10, 14 over 2. There's infinitely many ways you can write it as an integer over an integer. So 7 is also rational. If you have 0, you can write it as 0 over 3 or 0 over 10 or 0 over any non-zero number. So that would be an integer over an integer. So 0 is rational. However, so this is rational, rational, rational. However, if you have 3 over 0, there's a problem because division by 0 is undefined. It's not rational. That doesn't mean it's irrational. It's not even real. It's undefined, so it doesn't fit into any of our categories. Okay, let's go back. So irrational numbers would be, if you think about the prefix ir means not, like irregular. Irrational numbers are going to be numbers that are not rational, but they have to be real numbers. Real numbers that are not rational. Now, if you want to think about the decimal forms of rational and irrational numbers, if you're thinking about a rational number, in its decimal form, it would either terminate. For example, if you had 1/4, in its decimal form it would be 0.25, and that terminates. Or it would repeat. For example, if you had 1/3, in its decimal form you have 0.3 repeating. But if it's irrational, in its decimal form, it's not going to terminate. And it's not going to repeat. Okay, here we see and. So both of these have to be true, non-terminating and non-repeating, whereas for rational it was terminating or repeating, one or the other. Okay, so both rational numbers and irrational numbers are real numbers. These are the numbers you can map to a number line. So these are the rational. This is the union of rational and irrational numbers. Okay, and then our last two sets of numbers are imaginary and complex. And it's very common for us to use these two words interchangeably, but technically they're not exactly the same. So complex numbers could be real or imaginary. So in general, we say that complex numbers take on the form a plus bi, where a is the real part and bi is the imaginary part. And a can be 0. If a is 0, then you just have the imaginary part. B can be 0, and if b is 0, then you just have a real part. So it could be just real, and it could be just imaginary, or it could have some of both. And remember, imaginary numbers come from taking the square root of a negative. So I is the square root of -1. So imaginary numbers are multiples of I. Okay, I is known as the imaginary unit. All right, well, let's go ahead and make a little tree diagram of how these kinds of numbers fit together. So complex numbers would be at the top because all of the other kinds of numbers fall within the set of complex numbers. So now we're going to break the complex numbers down into two subsets. We have the real numbers and we have the imaginary numbers. Everything real is complex, everything imaginary is complex. Now we're going to break the real numbers down into two subsets. We have the rational numbers and we have the irrational numbers. Everything rational is real, everything irrational is real. So everything rational is complex and everything irrational is complex. Everything above it, if you follow back through the tree, everything above it it's a subset of everything above it. You can break down rational numbers into those that are integers. So if you think of rational numbers as numbers you can write as a fraction, remember we said 7 could be written as 7/1, so it's an integer and it's rational. And then you have some that are non-integers, like 7/2. You can't write that as an integer. Okay, we can break the integers down into those that are whole numbers. So remember that would be 0, 1, 2, 3, etc. And so then the other ones would be the negative integers. So the negative integers are a subset of the integers, which is a subset of the rational numbers, which is a subset of the real numbers, which is a subset of the complex numbers. And lastly, we can break down the whole numbers into 0 and the natural numbers. Okay, now the last thing we're going to do in this lesson is take a look at a set of numbers and classify each number. Is it natural, is it whole, is it rational, etc. Okay, so take a moment to write down set A. Set A has a lot of elements. Basically, we're just going to do this one example instead of doing a whole bunch of different ones. So we have all different kinds of numbers in this one example. Now, after you've written them down, you'll notice that you could simplify a few of them. So I would advise you to simplify before you go further. So if you want to, you could simplify the square root of -2. That's the same thing as I square root 2. And you could simplify -8/2. That's -4. And you can simplify I squared. We didn't talk about it earlier, but hopefully you remember from Algebra 2 that I squared is equivalent to -1. And you could also simplify I cubed. So if I squared is -1, then I cubed could be thought of as I squared times I, and that would be -1 times I. So that's the opposite of I. Okay, so let's look through the list and find all of the elements that are natural numbers. Remember, those are the counting numbers, 1, 2, 3, etc. So go ahead and pause and figure out which ones you think fall in each category, and then you could play and we'll compare. Oh, before that, I missed one that we could simplify. Square root 25 is 5. Okay, so the natural numbers are the numbers that we can count, 1, 2, 3, 4, 5. So I'm seeing 5, and I'm seeing square root 25. All right, the whole numbers, 0, 1, 2, 3, 4, 5. Well, I don't see 0 in here anywhere, and we already know that other than 0, the rest of the whole numbers are natural, so we can just repeat those. Integers, the whole numbers and their opposites. So we have -3. We have -4, which was -8 halves. We have -1, which was I squared. We have 5. We have square root 25. Rational numbers. Okay, everything that's an integer is also a rational number. Remember, integers are a subset of the rational numbers. So any integer belongs to the rational numbers. So that means anything we've already listed, we're going to list again. Anything we listed in the integer list, we're going to list in the rational number list. And then in addition to that, we have 2/3. Don't include 7/0. Remember, we can't divide by 0. We have 1/9. And I think that's it. Okay. Irrational numbers. Those would be real numbers, so nothing with I in it, real numbers that you cannot write as a fraction. So we didn't really look at examples when we were defining them, so here's our chance to look at examples. Remember, pi, if you write it out as a decimal, it's non-repeating, non-terminating. And square root 13, if you write it out as a decimal, non-repeating, non-terminating. And I think that that is it. Okay, and then lastly, the imaginary numbers. Anything that's a multiple of I. So we have I square root 2, we have I itself, and we have the opposite of I. Notice I'm not including I squared because I squared is -1, so it's not actually a multiple of I. Notice that in none of these lists we included 7/0. Okay, 7/0 is not defined. It doesn't belong in any number set. Okay, great. So that's the end of our lesson. And next, your job is to work on the assignment. So we did some problems from 2 sections of Chapter R. Chapter R is R for review. So page 6 is from section R1, and page 17 and 18 from section R2. So we're not doing every single thing in the chapter, we're just picking out some of the main ideas. And I know you don't have your book yet, so there's a PDF of the book on Canvas and also of the answers. So your goal is to work out all the problems and check your answers. You always need to check your answers. It's kind of pointless to do homework without checking your answers. Do your best to correct any mistakes. And if you don't understand your mistakes and you need help, then you want to ask for help. So if you finish it all, you understand it all, you don't have mistakes that are unresolved, then you're ready to submit. And to submit, you're going to send me the photo of the notes, the worked out assignment, and it should show evidence of checking your work. So that evidence maybe is however you like to do it. Maybe you like to put a star next to correct ones, or maybe a check mark. Maybe if they're incorrect, you circle them or you put a question mark or something. I'm sure there's a lot of different ways to do it. You're just going to find a way that works for you, and hopefully it will be clear to me what you're doing. Okay, now you can go ahead and submit that whenever you're done, but if you still have questions that you want to ask before submitting it, then plan on just asking those questions next time we meet. Thank you, everybody. Remember, you can return to our meeting room during the class period if you have any questions. I'll see you later.